So sorry about that. The last question truncated, so you didn't get to hear the last one about Donna. And then I had a fifth one that got cut off. So let's get those last two problems done again. So we're going back to number 4, where Donna can paddle her canoe. In still water at 5 kilometers per hour. Period. She is canoeing on a river that is flowing at 3 kilometers per hour. How far upstream? Can she travel? If she must return, to her starting point in 3 hours. So extraordinarily different problem in that they tell us the rate of the canoe in still water, they tell us the rate of the current, and we want to figure out how far, a distance. So we still have upstream, downstream. And we still have rate times time equals distance. So here's where it gets strange. Upstream, normally we take the boat and we subtract the current from it. And downstream, it's the boat being sped up by the current. But in this problem, they tell us that the current is 5, or the boat speed is 5. And they tell us that the current's speed, its rate, is 3. Okay? Now, the other thing that's strange, and this goes again, like I said before, back to the chapter 3 and 5, when you were given a total and 2 unknowns, one is x, one is total minus x, and what we have is 2 times that have to add up to equal 3. Now the question asks for how far upstream can she travel if she must return to her starting point in 3 hours, so that's where the upstream downstream comes from. But the question that they're asking us to solve for is distance. So since they want to know how far upstream, I want to solve for how long upstream. So if x goes with upstream, then 3 minus x will go with downstream. Now, in order to get the equation, all I have left for me is to multiply straight across. And I don't have a distance number because that's actually what I'm solving for. So for the rate on upstream, 5 take away 3 is 2, and 2 times x is 2x. For downstream, 5 plus 3 is 8, times the time 3 minus x. Now, the distance that she's going upstream would be the same as the distance of going downstream. So that's where we're going to get our equation in this problem, is by taking from this column and setting those two guys equal to each other. So I'm going to get the distance upstream is going to be the same as the distance downstream. So we go ahead and we solve this. And we get 2x equals 24 minus 8x. And we add 8x to both sides. And we get 10x equals 24. And we divide by 10. We can simplify by 2 to 12 fifths. And then we're going to get x equals, and we can round it to, or not round it, but convert it to a mixed number. 5 goes into 12 twice, which is 10 with 2 left over. Now that's not the answer because the question has asked us for the distance. How far upstream? So we're going to plug the 2 2/5 into the distance expression for upstream. So we're going to take 2 and multiply it by 2 2/5. Well, I'm going to convert it back to an improper fraction. That gives me 24/5. And then what I end up doing is 5 divided by 24 goes in 4 times with 4 left over. So for our answer, we're going to get 4 4/5 kilometers. And I get the kilometers from the rate label. And, again, we could verify with the second equation here and say, well, 8 times 3 take away 2 2/5 would give me 3/5, which would give me 24/5, which is the same as what I have here. So that's verification that I've done it right. All right, let's look. We have the last one to do that got totally taken off. And this one is a jet can travel 950 kilometers per hour with the wind and 700 kilometers per hour against the wind. Find the rate of the plane Sorry about that. Of the plane. In still air. And the wind speed. Okay, so this one is totally weird in that there's nothing about time, there's nothing about distance. All we know is with the wind and against the wind, rate. So we're going to only focus in on the rate part of our chart. So we're not even going to do a full chart on here. So we do have with wind and we have against wind. And all we can write is with the wind, it's P plus W, and against the wind, it's going to be P minus W. So how do we actually solve this problem? Well, we take the information that's in the problem, and it says the jet can travel 950 kilometers with the wind. And it can travel 700 kilometers against the wind. So at this point, that's all I need, and I can solve by adding to eliminate. And I get 2p, my w's eliminate, equals 1650. I divide by 2, and p goes into 16 8 times evenly, into 5 twice, which is 4 with 1 left over, and into 10 5 times. So this is a jet, even though we wrote p, and the jet is going to go 825 kilometers per hour. To figure out the wind speed, I'm going to take this number and plug it into either original equation. So I'm going to bring that down here, and I get 825 plus W equals 950. Subtract 825 from both sides. Do a little renaming. And we get the wind is 125 kilometers per hour. And then I could verify by plugging information into this equation, and I look to see if 825 minus 125 actually equals 700. And the answer is yes, it does. So that means these answers are good. All right, now we've completed the notes. All right, good luck.